going to begin section 6.2, which is going to be about factoring trinomials. And I want to preface this section by telling you that if you are using the Math Lab Help Me Solve This buttons and View an Example buttons, that is not going to help you in this section. Okay? I'm going to teach factoring of trinomials differently than what your book teaches. Your book is going to teach a trial and error method, it's going to teach a grouping method, and all of that works, but my way is easier, I promise. Okay? And so what we've talked about previously in this class is how to multiply. In chapter 5, we talked about how to multiply binomials, where we would say we're going to multiply x times x and x times negative 5 and 3 times x and 3 times negative 5 and combine our like terms, and you would get this as your answer. Well, now in factoring, remember, factoring is taking apart something that's been multiplied and breaking it into two or more smaller things that are going to that can get multiplied together to give you what you started with. So essentially, we want to break down this trinomial into the binomials that multiply to give it. And so what we're going to do is we're going to use this method I'm going to call reverse FOIL. And I made this name up. You're not going to find that name probably anywhere else. The reason I call it reverse FOIL is because you do the opposite of FOIL, right? If FOIL is putting it together, we're going to undo that. We're going to do reverse FOIL. And so I could give you a series of steps to follow. That is probably going to be a little more complicated than just telling you to watch a few examples. So first thing we're going to do is we're always going to try to factor out the greatest common factor. That again is number one priority every single time. Just like when we talked about with grouping, we're trying to take out the greatest common factor first. Same thing here. Now, if your polynomial cannot be factored, it is considered to be prime. Now, let me make sure you understand something. I am not going to give you many, if any, at all, on your test that are prime. If you go through and tell me that every problem is prime, you're not going to do well. Okay? It does not mean it's prime if you don't know the answer. It's prime if it cannot be factored. There's a difference. I've given tests before where there were 10 short answer questions where they had to type out or write out their answers, and I told the students none of these are prime, and I had people put every problem as being prime because they just didn't know the answer, so that's what they put. This method is not super difficult if you pay attention to what is happening. Okay, so as we get going through this, if at any point you say I don't understand, I need help, then you need to make sure you let me know. Okay, shoot me an email. If I need to Zoom with you or something, we can always do that, because this shouldn't be something that's super difficult for you, I hope. So let's just look at some examples. We're going to start here, and really this is a one-step process, but you've got to know what some things are telling you. Okay, so first of all, when we factor a trinomial, it is always going to factor into two binomials. So I'm going to put my two sets of parentheses, because then I'm just going to fill in those parentheses and we should have our answer. Now, the first term in each binomial, it's going to be this number, is always your variable. So in this case, y is the variable, y is the first term. Again, that's always the case. The second number in the binomial, those are going to be two numbers that will multiply to give 20. And because this sign is addition, they need to add to give 12. Okay? Need to add to give 12. Well, what two numbers will multiply to give 20 and add to give 12? Well, if you think about the numbers that multiply to give 20, you've got 1 and 20, you've got 2 and 10, you've got 4 and 5. Well, 2 and 10 obviously are going to add to give 12, and so we can put those two numbers in. And it doesn't matter which one you put first. If you want to put the 2 first and then the 10, that's fine. Now, you'll notice here I'm going to put the numbers in and then put the signs in. And so this sign, because it is positive, tells me that these two signs here have to be the same. And we can go into detail about why that is if we need to. But that sign being positive says these two signs have to be the same. And if that's the case, this sign always goes to the biggest number. And so that means the 10 is positive, and since they're the same sign, the 2 must also be positive. And so if you want to take that then and multiply it together to check, you could. You would see that you do get that trinomial when you FOIL. The key to this is knowing what the signs tell you. This last sign, this one down here, tells us what the numbers need to do to get the middle number. It also tells us if the signs are the same or different. Okay, the first sign, all it does is go to the biggest number every single time. So, with that in mind, look at the next one. If we, again, factor this, we're still going to look for that greatest common factor. We want to stay in a habit of that. Most of these are not going to have a common factor. This one doesn't. The one we just didn't. And so we're going to start by putting our 2 sets of parentheses. And again, our first term is t in both binomials. And now we're looking for 2 numbers that will multiply to give 32. They need to add to give 12. Now, not negative 12, just 12. We're not worried about the negative. We'll take care of that in just a minute. So what multiplies to give 32 and adds to give 12? Well, again, if you think about all the things that multiply to give 32, there's 1 and 32, and 2 and 16, and 3 and 8. Still not going to work, right? I'm sorry, 3 and 4. I'm sorry, 4 and 8. I'm off today. 4 and 8 is going to work, right? So 8 and 4 are the 2 numbers. And again, because this sign is addition, it tells us the signs need to be the same. This one goes to the biggest number, so it's a negative 8. Since they're the same, then this one is also negative. Again, there's our final answer. Again, hopefully not a whole lot to that. So try the next one. Again, there's not a greatest common factor. If there were, then obviously we would try to take that out. In this case, there's not. And so we're going to have our 2 parentheses with x being our first term. This time we're looking for 2 numbers that multiply to give 18, that add to give 9. Again, think about what multiplies to give 18. 6 and 3 will multiply to give 18, and they add to give 9. And then again, this sign tells me the signs are the same. This one goes to the biggest number, so the 6 is positive. Since they're the same, the 3 is also positive. If you have any questions about any of those so far, let me know. I want you to pause the video, try the next one on your own. I'll give you 3 seconds to pause the video. Alright, so on this one, if we continue, again, there's not a greatest common factor. And so we're going to make our 2 parentheses and put our y in as the first term. And now we're looking for 2 numbers that multiply to give 24 that will add to give 10. And some of you are saying 6 and 4. Some of you are saying 12 and 2. So the question becomes, well, which one's right? Well, because this last sign is positive, it tells us the numbers need to multiply to give 24 and add to give 10. Well, 12 and 2 subtract to give 10. 6 and 4 add to give 10. And so it has to be 6 and 4. And then again, the sign that we got circled there tells us the signs are the same. They're both going to be negative because the first sign is negative. If you use 12 and 2, it does not multiply back together to give you what you started with. Now, had this sign been a negative, then it would have been 12 and 2 because the numbers would have needed to subtract to give 10. 12 and 2 would do that. Okay, so again, that sign is very, very important. It does tell us what our numbers need to do. That helps us determine the right numbers. If you have any questions about those, obviously let me know. Now, on the next one, very similar to what we've been doing. There's not a greatest common factor, and so we're going to start by making our two sets of parentheses. A is our first term, and we're looking for two numbers that multiply to give 22 that now subtract to give 9. So now this sign is subtraction, so they need to subtract to give 9. And 11 and 2 will do that. And now because the sign is negative, it tells us these signs in our binomials need to be different. And so this sign goes to the biggest number. So the 11 is negative. Since they're different now, the 2 is positive. And so there is our final answer. Now, on the next one, same deal. R is our first term. There's not a common factor. We're looking for two numbers that multiply to give 4 that will subtract to give 3. Well, 4 and 1 subtract to give 3, and they multiply to give 4. And so the signs are different, again, because this one's negative. The biggest number gets this sign, which is negative. So the 4 is negative. Since they're different signs, the 1 must be positive. Now, try the next one on your own. Again, I'll give you 3 seconds to pause the video and try that one. All right, so if you did this one, again, there's no common factor. And so our first term is going to be R. And we're looking for two numbers now that multiply to give 16 that will subtract to give 6. So think about that. What multiplies to give 16, subtracts to give 6. Hopefully you come up with 8 and 2. Again, the signs are different. The biggest number gets this sign, so it's a negative 8 and a positive 2. And there's the answer. Now, move on to the next one. Again, no common factor, so M would be our first term. This time, though, we're looking for two numbers that multiply to give 5 that add to give 2. Well, multiplies to give 5. 5 and 1. And 5 and 1 don't add to give 2, and so because of that, there is no option. So this one has to be prime. Now, here's what your book would do on each of these. Your book on these would tell you to do a trial and error method, where you try all the combinations of numbers that give you. Let's look at this one for a second. This one at the top. Your book would say, well, think of all the possibilities of numbers that multiply to give 16. So you do 1 and 16, you do 2 and 8, you do 4 and 4, and then it would say, okay, of those combinations, which ones are going to give you negative 6 in the middle? So you start trying a bunch of numbers, and what happens is, in your book especially, it says wrong answer, wrong answer, wrong answer, wrong answer, wrong answer, until you finally get to the right answer. Well, to me, that just seems dumb to go through and do a bunch of wrong answers and multiply, wrong answer and multiply to check, when if you know what the signs are telling you, you know very quickly. So when you get to one that's prime, you don't have to think about, okay, 5 and 1, 1 and 5, because they'll be different. And so I have to multiply that out and see what works, and then try everything, and then they go, oh, well, it didn't work, so it must be prime. Again, that just seems dumb. If I know what I'm looking for, why not just look for that? And if it's not there, then we know it's prime. Because what your book does, it says, well, you got to try all the possibilities with all the signs. So you would have to try 5 and 1 and 1 and 5 and negative 5 and negative 1 and negative 1 and negative 5. And all 4 of those possibilities are different. And so your book would say, well, try all of those, and when none of those work, well, then you know it had to be prime. Again, if you know what you're looking for, very, very quickly we can knock out this and know that it's prime or not. If you have any questions about any of these we've done so far, please let me know. So look at each of these. So here in this first one, it is slightly different because it has two variables, right? It has an A and a B. So we're going to factor this the same exact way we've been factoring, with one minor difference. So you'll notice here there's not a greatest common factor. The first term has B's only, the last term doesn't have any B's, and so there's not any common factors. So we're still going to factor it the same way we've talked about. This time though, our first term is going to be B, and we know it's B because B times B, if we were to multiply, would give us the B squared. And the only thing that's different here is that now our second term is going to have an A in it. Well, why does it have an A? Well, because when I multiply something A times something A is going to give me this A squared, which is what we want, right? Now here's where people mess up sometimes. I see people that will look at this middle term and they'll see this A, B together and they panic and they go, oh no, I got to have a B in there with an A, and they just randomly stick a B in there. You do not have to force the A and B to be together. When you do this correctly, that A and B are going to end up together. Because when you do your outer and inner terms, when you multiply those two terms, you're going to have an AB. When you multiply these two terms, you're going to have an AB. And so that AB is going to end up there when you multiply. There's no need to force it together, okay? So as we're doing this, again, we don't want to force anything. We just want to do it like we've been doing all the others. So we're looking for numbers that multiply to give 4 and subtract to give us 3. Well, 4 and 1 would do that. And again, our signs are different. Biggest number gets the negative. So the 4 is negative, the 1 is positive. And so now we have our final answer. Now, one of the mistakes people often make doing this is they try to memorize what the signs are going to be based on the original problem. I do not recommend you do that. Because sometimes that works, but then sometimes it doesn't. And so you'll notice on a lot of mine, a lot of the ones we've done so far, the signs, if the original signs were negative and positive or positive and negative or whatever, my answers all typically look the same. Well, I usually put the bigger number first, but you don't have to. And so like in this one, I put the 1 and then the 4. Well, my signs are positive and negative, but if you go back and you look at this one, for example, the first example here, where both signs were negative, well, I had a negative and a positive in the answer. And so it's based on where the numbers go. That's why I will put the numbers in first and then put the signs in to make sure I have the right signs. If you don't put the right signs, it is wrong. Okay, so be aware of that. Now, we're going to go across the top here to the right, do it next. And so it is very similar. It also has two variables. But again, there's no common factor. So we're still going to factor this one just like we've done all the others, with R being the first term, S being in the second term. And then we're looking for two numbers that multiply to give 8 that are going to add to give 6. Well, 4 and 2 will do that. And so the signs are going to be the same, both going to get the negative. And again, we have our final answer. If you have questions there, let me know, and we can try to address any of those that you have. Now, look at the next one. The next one does have a greatest common factor. We've kind of mentioned that we're looking for a common factor, but we haven't seen that in any problems yet. Now we do see a common factor. You obviously can see that there are X's in every term, so that ought to be a clear indication. Hopefully also you see that 4 will go into each term. 4 goes into 4, 4 goes into 28, 4 goes into 40 evenly. And so our greatest common factor here is 4x squared, and you have to factor it out. If you do not factor it out, this will not work. Actually, it's cubed, not squared. Sorry. 4x cubed, because there's 3 x's in every term. And so if you don't factor out that common factor, you will not get the right answer. You've got to take the common factor out. That is priority number 1. Now, once you've done that, we've talked about how to find the greatest common factor. When you divide that out, you're going to be left with x squared minus 7x plus 10. Now, this 4x cubed is part of the answer. So we're going to bring the 4x cubed down. But then we still have a trinomial that can be factored. And so we have to factor it. You'll notice in your directions a lot of times it'll say factor completely, meaning you factor until you can't factor anymore. Okay? And so this trinomial can still be factored. And so we'll take out our x for the first term. And we're looking for two numbers that multiply to give 10 that will add to give 7. So 5 and 2. Signs are the same again, based off of this one. Both going to get the negative. And now we have our final answer. So again, if we can take out that common factor, we have to do so. And once we do, that common factor is part of the factored answer. So we got to make sure we get it out. Now, look at the last one. This time, we do have a common factor again. There's 2 x's in every term, and also each number is divisible by 3. So 3, 15, and 8 are all divisible by 3. And so when we factor that out, we're going to factor out 3x squared. And I'm going to recommend that you factor out a negative 3x squared, because you can do this reverse FOIL with the negative, but it gets kind of complicated. It's easiest to take that out so that our first term is going to be a positive x squared. So I definitely recommend that you do take that out, that negative out. And all that's going to happen are the original signs are going to change. So now 15 divided by negative 3 is going to be negative 5x. And negative 18 divided by negative 3 is a positive 6. And again, just subtracting exponents on the x's. And so this negative 3x squared is part of the answer. But we also have this trinomial that can be factored again using reverse FOIL. And so the first term is x. And this time we're looking for two numbers that multiply to give 6 that will add to give 5. Well, 2 and 3 multiply to give 6, and 2 and 3 add to give 5. Notice here 6 and 1 multiply to give 6, but subtract to give 5. So be careful again. There are several combinations of numbers where there might be a group of numbers that add to give the middle number and also subtract to give the middle number. And so you've got to be careful. In this case, they have to add to give 5. So 3 and 2 add to give 5. And the signs are the same, and they're both going to be negative. And so we now have our final answer. If you have questions about any of those, let me know. That is how we are factoring trinomials. I believe this ends section 6.2. We will continue into section 6.4 in the next video. If you have any questions about any of these, make sure you let me know. We'll try to address anything